Hola, mi clase. So we're doing 8.2 quadratic functions in vertex form. So still quadratics, that's squared, makes the U, all those good things. But this is vertex form. So we still have our A. Remember, that's what makes it stretch or compress and or flip upside down. Now we have x minus h squared and then plus k. So remember, that was same with absolute value. The h moves it left to right and the k moves it up and down. And so we'll look at and remember how that moves that. So it says, how does the graph of g sub x, where x squared minus 4, compares to that of f of x squared? So remember, this is our parent function. So our vertex would be at 0, 0. And then if I plug in 1 squared, 2 squared, right, negative 1 squared, 2, negative 2 squared, right? So this is my parent function. Wow, that was a pretty good U. Okay, that's this one. Now, with g sub x, it's minus 4. This is k. So remember, that's going to move it up or down. If it was inside the parentheses, it would be h, and it would move it left to right. So remember, when it's k, it's directly what it is, and so this would tell me to move it down 4, and then everything else about it would be the same, okay? So in a sense, right, I'd square 1, get 1, and then I'd minus 4. 1, 2, 3, 4. And if you notice, that's actually the same distance it was from the vertex here. See, it was 1, 1. Now it's 1, 1. So same, 2 squared is 4, and then I minus 4. 1, 2, 3, 4. Okay? But it also just shifts it so that it's still in the same, basically the same distance away from my vertex, right? This point is 2 away, 4 away. If I check, this point is 2 away, 4 away. So it doesn't change how wide or how compressed or stretched it gets. It just changes where my vertex is. Whoop, there we go. So the vertex is now at 0, negative 4. The axis of symmetry is still right here at x is 0. Domain is all real. Those x's will be anything they want. But the range definitely has changed. It's now y needs to be greater than equal to negative 4, right? Because x can be negative 4. And then it has a minimum, right? And that minimum is at my vertex of 0, negative 4. All right, so remember, k is the shifting up and down. So if we look at this one, this is our h, okay? And remember, our h is going to shift it left to right. And remember, I know that's a little tricky, but technically it shifts it the opposite of what's in here. Okay, so I'm going to sketch my parent function again. So 0, 0, 1, 1, 2, 4, 1, 1, 2, 4. Oh, didn't make it as nice as the last one. Okay, parent function. So h shifts it left to right, and it's always the opposite of what it says. So it's negative 3. Technically, it moves it over here to positive 3. We can always check that. Plug in 0. 0 minus 3 is negative 3. Right? 0 minus 3 is negative 3. Plug in. And square would be 9. That'd be way over here, right? If I plug in 1, 1 minus 3 is negative 2. Squared would get me 4. 2 minus 3 is 1. 1's or negative 1. Squared would get me 1. And if I do 3, 3 minus 3 is 0. Squared is why I get 0 here. And then it's just going to make a nice mirrored shape right here. Oop, totally missed my point there. Oh, geez. It's just getting worse. Hold on. There we go. So again, it's still the same distance. If you notice, 1, 1, it's 1, 1, it's 2, 4, it's 2, 4. Okay, so it, again, doesn't change any of that. It just shifts it one way or the other. So now my vertex is at 3, 0. The axis of symmetry is here at x equals 3. Domain is all real. Range y needs to be greater than or equal to 0. We still have a minimum, and it is at 3, 0. Okay, so minimum, remember, is the lowest it can possibly be. Maximum would be the highest point it could be. So H shifts left to right, K shifts up and down. So these have been shifted both. They want us to write the function and the vertex. So the best place I would start is at the vertex. So that's right here. This is the minimum of this one. And so it is at 1, -2. If I check, it's 1, 1 here. It's 2, 1, 2, 3, 4. Remember, that's like the same as my parent function. So I know that A has not changed, that A has not done anything. So I'm going to go x minus 1. Remember, H is always the opposite here, squared. And then I'm going to go minus 2 because my K is, in fact, negative. Oh, did I count that wrong? Is it a 3? It's a 3. I know, I can't count. Bear with me. It's still negative, at least. -3, so minus 3. I can count, I promise. 1, 2, 3. Okay, fixed it. All right, why don't you pause and see if you can try this one? Maybe you can count better than me. So I have the vertex at 1, 2. Did I do okay? 1, 1, 2. Okay. So then I would have x minus 1 squared plus 2. Okay. Opposite for H. Opposite for H. Same as K. That's what you got to remember. All right. Pause. Try this one. So I have vertex at -2. -1. So my function would be at x plus 2, again, opposite of H, and then minus 1 always matches K. And the reason there's no A is if I check, you'll notice it's 1, 1, 1, 1, 2, 1, 2, 3, 4, which matched that parent function pattern as well. Okay, I could always check it too if I plugged in 2. 2 minus 1 is 1. 1 squared is 1 plus 2 is 3. And if I see 2, 1, 2, 3, and it's where it's supposed to be. So you can always check it as well. But that pattern will always happen with the same as the parent function if there's no A there, is that it'll be 1, 1, and 2, 4, and so on. So this one says, how does the value of A, and that's italicized A, affect the graph f of x equals A, parentheses, x minus h squared plus k. So we have these two functions. F of x is the red one, and then we have a g sub x, which is the blue one. So if we look at f of x, it's a shift of our parent function because it's 1, 1, and it's 2, 1, 2, 3, 4. So it's just a shift of my parent function. And this is actually our function where A is not there. So it's x, and I went 1, 2, 3, so plus 3 because it's opposite, right? The vertex is at negative. Oh, I switched my y's and my x's. I apologize. Hold on. So it's at 1, -3. So I'm going to go minus 1 squared and then minus 3. That's my f of x. So then we need to see what happened to A that affected f of x. So it's clearly narrower, it's tucked in. So it's the A means it has to be greater than 1, okay? So if we look, this was 1, 1 away, now it's 1, 1, 2 away. So that's been shifted by 2. If I look here, it's 1, 2, 1, 2, 3, 4, 5, 6, 7. It doesn't fit, but it would be probably up here. So if we check, I need it now to be at 2 away instead of 1 away. So if I plug in, same over on this side, it was 1 away, now it's 2 away. So if I plug in 0, okay, 0 minus 1, they have the same vertex. We're trying to find what A is. Still the same vertex, minus 1 squared, and it's still minus 3. So 0 minus 1 is negative 1. Squared is 1. 1 minus 3 is negative 2. That's here, but I need it at negative 1. Okay? And so that's not going to help me, right? I got to shift it. So since it's been moved now by 2, 1 away, 2 away, we can check that. Okay? So if I plug in, again, I'm checking my 0. If I plug in 0, 0 minus 1 is negative 1. Negative 1 squared is 1. Here, I'll do it down here. A little much to take care of, right? To keep track of. So that's negative 1 squared minus 3. So negative 1 squared is 1. 2 times 1 is 2. 2 minus 1 is negative 1. And if you see, it's right where it should be. So it's because this rate of change has changed as well. It was 1, 1, now it's 1, 2. Okay? And same on this side because it's mirrored. 1, 1 becomes 1, 2. So that's where this A is being affected and changed. That's why now if I went 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, it would be way up here. And that's why this one doesn't show up. So it's that rate of change that's changing. It's the same when we did absolute value, right? We checked those slopes. If it doubled, it's 2. If it cut in half, it's a half, right? So it's that slope. I have to check this slope right here. 1 over 2, slope, rise over run. Same here. It was rise of 2 over by 1, okay? And it's not a constant change, so it's a little harder to check, but it is still doubling the amount because this initial one was a 4 over 2, which is, right, it's a double of that, and then it would change. Okay, so the pattern is changing, and that's why we are checking that slope. Okay, and my initial slope was just 1 over 1. And now it's 2 over 1, and then if I had to check, this would be 2 over 4, and I would need to double. It would end up doubling my slope here as well. Okay, so it shows that my slopes are still doubling, and that's where that 2 comes from. Okay. So we're going to graph these now that we have HK. Okay, I'm going to show you how to graph these so that we can graph them no matter what I'm given. All right. So we have the vertex. Vertex is going to be at negative 1, 4. Negative 1, 4. It's going to have a maximum at that negative 1, 4, right? It's going to be upside down because it's negative. So it's going to go this way. All right, we know the axis of symmetry already. It's right here at negative 1. So you can see I can fill in a lot of information just from my vertex. My axis of symmetry is x equals negative 1. My domain is still all real. And my range is going to be now y has to be less than or equal to 4. So I can fill in all of this just from my vertex, and then to graph the rest of it, I need to use this slope, okay? So initially, right, we have the same A from the last one. So this is kind of like my slope. So I'm going to go over 1 and down 2, and then I'm going to mirror it here, 1, 2. But because this is now squared, it's going to get bigger. So remember from our parent function, it was 2, 4. So now it's going to be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Everything doubles. Okay, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, because it was 1, 2, now it's 2, 8. Doubles. It's going to make it much, much narrower. I can always check these if I plug in 0, right? We can use a calculator, plug all these in, and make sure they work. So you can always make a table, fill in some points using your calculator. We have the Vertex, so I would always use 1 over and then 2 over, so you can plug in 0. You can plug in -2. They would just mirror each other, but you can always plug them in as well. So like if I plug in 1, 1 plus 1 is going to be 2. 2 squared is going to get me 4. 4 times -2 gets me -8. But then I add 4 and I get -4. And you can see when I plugged in 1, I got 4. Okay, so it's all based off that parent function. Now I just get to mirror it across my y-axis, so I really don't have to find too many points. I can just find the 1 and then mirror its partner. So I can just remember axis of symmetry means it's mirrored. So if it's 2 here, it's got to be 2 here. That's what's really nice about the axis of symmetry. All right, why don't you try this one? If it helps, like I said, you can plug in some points after you find the vertex and then see if you can graph this one. So hopefully you said the vertex was at 2, -3. That would make the axis of symmetry x equals 2. Our domain is still all real. My range is now that y has to be greater than or equal to -3, and it's greater than because it's going to be open upward, which means we now have a minimum at 2, -3. So 2, -3, axis of symmetry. Now my a is half. That's going to cut that slope in half. So instead of going 1, 1, I'm going to go 1 1/2. I'm going to mirror that here. Same when I did 2, it was up 4. So instead it's going to be 2 and up 2. And then I'm going to mirror that over here, 2 and up 2. So I'm going to, I totally missed my dots. I'm going to have this compressed graph. Okay, and you can see it's a little wider than my parent function. Okay, again, you can always plug in some points. So if I plug in 0, I get 0 minus 2 gets me -2. If I square that, I get 4 because I'm squaring -2. If I times that by 1/2, I get 2, and then I minus 3, I get -1. And if I check 0, there it is at -1. And I have its perfect match of symmetry on this side as well. I can plug in 1, same idea. 1 minus 2 is -1. Square it, I get 1. Times it by 1/2, I get 1/2. And minus 3 should be -2.5. And if you look, 1, -2.5. So it's up to you on which way you want to do it. But you can see my points do work. And if it makes sense to you to use kind of like the pattern of the parent function, you can do that, or you can fill in a table like we did in 8.1. Okay, it's completely up to you. And the nice thing is you only need to find 2 on one side to mirror it on the other side, meaning since this is at 0, -1, and it's 2 away from my axis of symmetry, its pair should be 2 away on the other side of my axis of symmetry. Same here, this is at -1, 2.5, -2.5. It's 1 away from my axis of symmetry, so I go 1 away from my axis of symmetry and put another point. All right, so the main things to remember is that H moves it left to right, and it's always the opposite of what's in the parentheses, okay? H, I'm going to put lowercase h, italicized h. H moves left to right, opposite of listed, or however you want to put that for you. For me, that makes sense. Opposite of written, opposite of wherever it is, right? And K, italicized, moves up and down as listed. Meaning if it's positive 4, you go up. If it's negative 4, you move down, right? All right, so here is your function to graph. Notice nicely you don't have an A, so that's kind of going to make it a little bit easier. So this one will be its opposite, and this one will be exactly as it says. All right, until next time, adios.